We've got water decomposing into hydrogen and oxygen gases. You can do this with electricity. We have some apparatus here. I don't know if anybody's done it for a while. Is this balanced, Johnson?
No.
If I'm taking up a question, you better be listening, especially if you ask for it.
Yeah.
Okay, so we know we've got 25 grams of water. We want to know how many moles, how many molecules. With me? Molar mass of water, 18.02 grams per mole. Do I need the molar mass of oxygen? Why not, Ankit?
Just any which includes the molecules.
Yeah, we only want molecules, and if we find molecules, we can also find moles. So, what value are we going to put underneath oxygen that's going to help us? Avogadro's number. Now, whether you're doing dimensional analysis or whether you're using formulas, this information should be written down before you start so that you've got everything there. Okay, dimensional analysis first. Johnson,
Yes.
what are the units that we're looking for?
Moles? Molecules?
Molecules. So, Nicola, what should we start with? We're going to start with Avogadro's number. This is for molecules of oxygen and moles of oxygen. Because I need information about this, I'm going to use the information from the water that they give us. So you have to convert between oxygen and water, and we use that using, anybody? Rhymes with mole ratio? Mole ratio. So, there's 1 mole of O2 for every 2 moles of water. Got to get rid of moles of water. I've got molar mass. So now I've got rid of moles of water, but I'm left with grams. Got to get rid of this, so I'm going to multiply it by now the only unit I have left is molecules of O2. Now, by finding molecules first, you do the math, you get molecules of O2, but we also want moles. But if we cover up this first part, if you cover up that first part, what are the units that are left? What unit is not canceled out anymore?
Moles of O2.
Moles of O2. So you do the math to figure out molecules. You do the math again without the first ratio, and you've got the moles. So you don't have to write it out twice. Okay, Sasha, you ready? Formulas. First, find the moles using that formula for water, because it's the one you know two pieces of information about. So that's going to give us moles of H2O, but we want moles of oxygen. What you want goes on the top, what you want to get rid of goes on the bottom. You okay with that? So that's one answer. And then that's moles of O2 times it by Avogadro's number. Now you've got molecules. So instead of using, so for this question, instead of using N is equal to M over M, then mole ratio, and then mass, we went N is equal to M over M, and then we went to Avogadro's number. Okay? So that's the difference. We've got our moles, our first equation, mole ratio, and then we use the other formula with moles in it, N is equal to N times Na. And that's 227, number 6. Molar mass of titanium?
47.87.
And what is the molar mass of titanium oxide? TiO2. Thank you. All right. So, we want grams of titanium. Do we have a value up there that has grams in the ratio for titanium?
Titanium? Yeah.
Yeah. So we're going to start with the molar mass of titanium. What is the mole ratio of titanium to titanium chloride?
1:1.
So what we just did is product to reactant. That reactant happens to be a product in the previous equation. So, what is the ratio of the product, titanium chloride, to titanium oxide? It's the mole ratio. Now I've got moles of titanium oxide, but I know 1 mole has a mass of 79.87 grams times 1,000 grams. So 47.87 times 1,000 divided by 79.87.
It's like 349,690. Is that the other one? Oh, my bad.
Can't be bigger than 1,000.
The other one, 599.
599?
Oh, that was the other one.
Okay? We good? Any other questions? Is there another part? Are we finished? That's it? Okay. Or 70 over 100. It's supposed to be used. If we want an extra 10%, we actually are using 110%. So 110% is like 1.1. Some of you that go shopping and are on a budget have to factor in the tax that you're paying when you're purchasing your whatever. How much is tax?
13%.
So if you figure out that it's $30, you know to multiply by 10, right? You've got to, but maybe you can't do 13% in your head. So if you do 15, 10% of 30 is 3, and a half of that is $1.50. You know you're going to add at least $4.50, right? You got to be able to think when you're shopping, otherwise you walk out of there and you go, I have no money. I have no money. I just spent my budget, but I only bought one thing. So, got to pay attention. Okay, propane is a common fuel used for heating and cooling. If you have 4 moles of propane to burn, how many moles of oxygen gas do you need to ensure complete combustion? So, if your unbalanced reaction is C3H8 plus O2 to make CO2 and H2O, you've got to balance that first. We're not doing anything new except we're adding one minor calculation, okay? So balance that chemical reaction like you did before. Anybody?
1534.
Yeah? Okay. So, we know we've got 4 moles of that. We want to figure out how much oxygen we need with 10% extra. So once you have your moles calculated, we have 4.0 moles of C3H8. You're going to figure out how many moles of oxygen that actually is. How do you convert between moles of substance A and moles of substance B?
Mole ratio.
Yeah, I'm going to use your mole ratio, 5 oxygens to 1 propane. So how many moles of oxygen would 4 moles be?
20 moles.
So that's 20 moles, but we want to ensure this reaction goes, so we want to make sure we've got 10% extra. So you can either multiply that by 10% and add it, or multiply that by 1.10. Yeah,
22 moles.
it's 22 moles.
10%.
Are you okay with that? Okay, next example. Sodium plus chlorine makes sodium chloride. So you have 2 very reactive elements. They come together and make a very safe, not according to nutritionalists, but very safe compound chemically. Is this balanced? Nethu, What do you think?
Would it be 2 and then 1 and then 2?
What do you think there, Johnson?
Yes.
Yes. Thank you. Okay, so we've got 1/2 gram of sodium. What mass of chlorine needs to be used in excess? So, we need molar masses. What's the molar mass of sodium?
22.99.
What is the molar mass of chlorine gas? Okay, I'll do dimensional analysis first, and then I'll do formulas. So, we want to figure out grams of chlorine, so we have to use the molar mass first. Need to get rid of moles of chlorine, so we're going to use our mole ratio. That would give us moles of sodium, right?
No.
Sort of.
Yeah.
Yeah.
So now, 1 mole, 22.99 grams, times 0.50 times 1.1. Formulas. First, you're going to calculate what you can. So we're going to use 0.5 grams of sodium divided by the molar mass of sodium, which gives us moles of sodium. Use your mole ratio. Use your mole ratio to convert. Now, that gives you moles of chlorine. Multiply that number. Multiply that number by 1.10. And that will give you the 10% extra moles of chlorine. Now we come back and we use the other formula. You know moles of chlorine now. With extra, multiply it by the molar mass. So, whichever method you're using, you fill in the numbers. Who's doing formulas? Jordana. You are? Did you calculate the moles of sodium yet? Okay. Calculated the moles of sodium from the first step yet. 0.5 divided by 22.99. Anybody?
0.0217.
Okay. So how many moles of chlorine does that mean if the ratio is 1 to 2? Is it going to be twice as much or half? So 0.2175 divided by 2 is What?
0.086.
Can't be.
0.01087.
87.1.
Oh, will you just give me the rest of it? Oh, I'm sorry. I thought you were saying it was 0.08, not 0.01. Okay. Now, if you take that number and multiply it by 1.1, what do you get? You cleared it.
Yeah.
Can't be if you multiply it by 1.1.
Wait, why did you multiply it by the?
So, anyway you do it, you get 0.85 grams. So, this is the shortest lesson for this unit.